So now we're going to go from the pathogens to cleanup and disinfection. First thing on cleaning up the eggs is when the eggs arrive at the hatchery. We want to bring down the level of contamination on the eggs, so we need to fumigate them. You will see a very specific clean and dirty areas. So where the eggs come in, that's classified as dirty. Anything outside that is going to be dirty, but anything inside should be fumigated and clean. Similar to when people come in and they have to shower through the barrier shower to ensure that there's a definitive clean and dirty area. The only time this may change is if you bring the eggs in and you have to unpack the eggs prior to racking up onto the setter trays. First thing in terms of your fumigation chamber, you need a lot of air circulation, so the air needs to move around the chamber quite freely. If you're going to pack your eggs in like this, you're not going to have a chance. Same thing here, you see that the eggs are packed in so tightly you can't get the air around, and if you can't get air through the eggs themselves, you're not going to get the fumigant through them either. So you may be fumigating the eggs, but it's going to be completely inefficient. Also, wherever you take your clean fresh air supply, you want to make sure that it is genuinely clean. Here you'll see that what they're doing is taking their air supply from the supply. Bollocks, I'm not starting again. They're taking their eggs from the inlet. So where the eggs are coming in, they're also taking, which for the dirty area, they're taking their clean air supply from, which is obviously not going to be working. Other thing with the fumigation chamber, you're going to want the stop-go lights. So essentially, if the red light is on, that's going to be fumigating for 20 minutes, and then it's going to be purging for 40 minutes. So you're going to get in 1 hour, you're going to have a proper cleaning cycle. Once you're after your hour, you should be clear to go in there. If after 40 minutes you can't still go in there, that means you don't have enough air circulation. What I've always found is these wall fans, the big wall fans that restaurants use, are the most effective for moving air, hence why the restaurants use them. The ceiling fans are not very good at all, to be honest, at moving air around that kind of chamber. Other thing is, when you're purging the air, make sure that the circulation fans are still running. If you don't, you're going to end up with this line going through this sort of, where you've got a shortcut for the air to cut through, and the eggs that you'll see in the left hand corner of that fumigation chamber and the far right hand corner are going to be over fumigated because you're not exhausting the fumigant from them. Hence why if you walk in there after 1 hour and it's still very strong, you don't have enough circulation. I put this on just so that you got the numbers for the sort of percentages you want to use and how much you're going to use for your formaldehyde in the fumigation chamber, if indeed you're still using formaldehyde. To be fair, the majority of people still are, but there are other products out there. You can use bollocks, it's gone. Peracetic acid, but the issue with peracetic acid is quite corrosive. So this is probably the best thing I've seen to replace formaldehyde. It can do a lot of other things, but in terms of replacing the formaldehyde, this is really good against all the bad diseases, shall we say, and it's non-corrosive, whereas peracetic acid will eat through your trolleys, so you have to be very careful. The other weird side effect of peracetic acid is it turns all, if you right on your eggs in pens, which we do for traceability, it changes everything to green. So for example, if you've got grandparents where you will have each different line will have a different color, so you'll be writing in different color, it changes everything to green. So all of a sudden genetic security becomes an issue. One thing, if you're going to start fogging, you need to understand the size of the droplet that you want for fumigation. And I put this in because it's quite important. So what you ideally need is this cold fogging with a compressed air, which is between 5 to 10. So if it's ultrasonic, basically those particles are just too small, so when they hit the surface of the eggshell they're going to bounce off. So it's going to be dry, but it's not going to be disinfected. So although it looks very good when you walk in, it's not that efficient. Between 5 to 10, what you'll see is those will hit the surface of the eggshell, will coat the surface of the eggshell, but the eggshell remains dry. And then it will dry, as the things will actually dry out, they'll leave a coating on it, which works very well. If it's larger than 25, basically when it hits, it breaks. So you'll end up with the surface will get wet. As soon as you wet the surface of the egg, you're going to ask for problems, because you've also got a lot of airflow in that chamber, and if you have a wet surface, you're going to get a lot of cooling going through, so those eggs are going to cool down even more, and anything on the outside is going to be drawn in. Even if you're using a disinfectant, it's not going to be good. You're going to end up with a lot more bangers on your hatch. If you want to check the efficacy of your fumigation chamber, what I suggest is you make up a matrix within the chamber and you look for the extreme position. So essentially what you want to see is where is the airflow moving around and where are the points that it's missing. And then you will take those places, you will take a tray and you will just take one egg prior to fumigation and you will roll it across an agar plate. One thing you want to really make sure you avoid doing is putting a finger or a thumbprint on an agar plate, because then it will show up. It's a growth medium for bacteria, so anything on there will be highlighted. The great thing with agar plates is you can actually isolate the bacteria that you find on there. So if you see something that's really high numbers, you can have a look and identify what it is. So you will do that before you fumigate, then you'll fumigate, and then you'll take another example. One thing with the egg that you just tested, make sure you throw that away. Don't put it back in the spot, because that's now got a growth medium on it. So the bacterial development will be huge, so you need to throw that one away. After fumigation, you'll check another one within the same location, so very close to the first one. We'll call that before and after. It doesn't really matter what you call it, as long as you do it. Then we'll take, the number of samples is really up to you. The important one is afterwards you want to take, you'll have one more sample, but that will just be a control, so you leave that one closed. The reason you want that control is because if you've got an infected or you've got a dodgy batch of agar, then it will be highlighted in the control. If you see growth in that one, then all the other ones are invalid. You can also do a similar thing with peptone water and petrifilm. They'll still give you a bacterial count, so you'll be able to see if there's reduction in that bacterial count or not. The only thing is you can't do is you won't be able to isolate what it is. Hygiene monitoring, you want to do this regularly in the hatchery just to see what the numbers are. You need to do it on a dry surface, so don't do it when there's chick fluff around, or don't do it when they're wet. But you need to be honest with yourselves. This is a hatchery that I visited, and everything was, you see, it's absolutely perfect. perfect. This is not reality. In any hatchery, to be honest, any livestock operation, it's not going to be sterile. So you need to be aware that you will see some bad results every now and again. The good thing about getting a bad result means the result is real. So if you see everything is perfect, like on those examples, you know that there's a problem. Another thing you need to be aware of is where you're taking your air from with biosecurity. You'll see right out here, you'll see that what look like windows, there's no glass in them, so they're just open doorways, and they are taking air directly by your washroom, where all you see the blue bins in the corner there. Those blue bins are waste from the hatchery, and you put them directly where you're taking your air intake from. You see the same thing here. This is actually chick dispatch, the blue roller doors. Those are chick dispatch, and you see that the air is being taken directly from that area. Something that's not immediately clear on here, but if you look, that's their water tank, and you'll see that the lid is off. So again, you know, I didn't, to be honest, I didn't have the balls to climb up there and check inside, but I'm pretty sure if I had a look inside there, you would see some pretty nasty things. And this is the water that they were washing the hatchery down with. In terms of which chemicals you use, there's a whole bunch, to be honest, and this is the properties of each. So for example, why glutaraldehyde is so good, because it kills majority of things, you know. It's antibacterial, antifungal, antiviral, anti-spore. It's not incredibly toxic, so it's not too bad for the people. It's not corrosive. The cost, on the other hand, is quite high. So hence why we need to always have a balance between cost and efficacy. Formaldehyde, for example, is good because it also has similar properties, but the toxicity is high, whereas the cost is low. So it really depends on what you need to kill and what your budget is. You'll see there, just as another example, you'll see the parasitic acid. When you have parasitic acid, for example, or you have hydrogen peroxide, they're quite good examples until you get the corrosiveness. So whenever you see corrosiveness being high, avoid it like the plague, because even if the cost is low, like it is with hydrogen peroxide, the purchasing cost may be low, but your total cost, when you have to start replacing trolleys and doors and things, that's going to go through the roof. So just, you want to avoid those things as best you can. Something, if you remember back to your school days, whenever you mix chlorine and acid, it can be quite nasty, so you need to always be aware of these things because it produces chlorine gas. Chlorine gas, it smells a bit like pineapple and pepper. It's first used during the war. And the other one is ethanol and chlorine. So alcohol and chlorine produces chloroform. And when we come to cleaning, there's this thing we call the sinus circle. And the sinus circle is quite simple. It comprises of 4 elements, which is time, the amount of energy or kinetic energy that you put into something, the strength of the cleaning agent, so how strong is the chemical that you're going to use, and temperature. And there's this kind of, it's not really a law, but it's a good governing thing that You can reduce one, but you're going to have to increase another. So as an example, if we increase the amount of mechanical energy, decrease the amount of kinetic energy, but let's say more elbow grease, we can reduce the amount of time, and we can reduce the amount of temperature, so we can use cooler water, and we can have a slightly reduced concentration or efficient chemical. And you can move this around in whichever way. So if you have a much stronger chemical, you can reduce the other three. Problem with that is, of course, you're going to get with a more corrosive issue. If you push up temperature, increase also the kinetic energy, shall we say, then you can reduce the other two. So this really does allow you to modify how you want to clean something, because to be honest, the amount of energy that you put into cleaning it, like physical energy, or shall we say higher pressure water with warmer water, you can do it at a lower cost, and you can increase the amount or decrease the amount of time, decrease the amount of chemicals that you need to use. So when it comes to cleaning the hatcher, first of all we're going to do a dry clean, which means remove everything from the ceiling, walls, the cooling coils, put everything down onto floor level, pick it all up, put it into a bucket, and which would remove the majority of debris. Anything, if you see some dried in dirt on the floor, some egg yolk for example, use a scraper to take as much off as you possibly can, because it's still going to leave a residue. And then we're going to use a detergent. Detergent's going to need 20 minutes to soak in. Once it's soaked in, it's going to lift that dirt up off of the surface. And once that occurs, we can then go in and remove the rest of the debris. So we're going to do that with just water. Warm water is preferable. So once we've now got a almost clean hatcher, but not quite, so we need to allow it to dry properly, and to do that we're going to close the doors and we're going to put it on a heating cycle. So we're going to make sure it gets warm inside to dry that machine out. Now the reason we want the machine to be dry is because if you have these little porous surfaces, which all surfaces will be porous to some extreme, when it dries out you're still going to get these little pockets of water underneath, and in those pockets you're going to get bacteria. So when you put the final layer of disinfectant on, it's not going to touch that bacteria that's in those little pores. If you allow it to dry out properly, it will. So when it's dried out like this and you put disinfectant on, it's going to kill everything that's inside there. And then we're going to close it up again and dry that machine out, because we obviously don't want to be loading eggs in there that transfer into a wet machine. But at this point the machine is properly clean. So dry clean, detergent, rinse, dry, disinfection. Okay, that's going to conclude the